Don't worry, I'll let your professor.
Thanksgiving Wednesday. Yeah, I'll just do it that day remotely or something. And probably I'll make an announcement. I'll say, all right, Wednesday before Thanksgiving, here's your video. Go wherever you want, I don't have to come. You guys don't have to come. Everybody's happy, right? Okay. Okay. Well, let's talk about visualization, data visualization in Python, and we have matplotlib. I don't know. It's the matplot library, so I'm not quite sure how best to how it's pronounced. Here is references. Okay, so this is kind of where a lot of your stuff is going to be coming from. So I always recommend the original source reference. So there is matplotlib.pyplot. That's a function that we frequently use, and then there's kind of just more information about that. Question?
So, is like importing all these libraries by those specific names like universal syntax, because across like multiple like documents and programs I've seen, they all use like the same name of like importing numpy as NP.
Yeah, that's the convention. Import numpy as NP, import pandas as PD, import matplotlib.pyplot as PLT. That's the convention, and I mean, I don't know. It's we understand like that's just kind of part of the language in that we say LOL for like to indicate that we're kind of just joking, or this is supposed to be intended to be funny or something like that, right? And like, do you have to say that? Like, no, but this is that's convention. So that's what I wrote. Always do that. That's the convention. You don't have to follow convention, but people will have a harder time understanding what it is you're doing, right? All right. So Matt, another question. Oh, the quiz is not up. Okay, let me fix that. Here we go. Okay. Oh, you know what? The dates are wrong. Available until
Double digits now.
Yeah, we are. Okay, so simple plot is you can give it, so first I'm going to just make a sequence from 0 to 2 pi. So x is going to be a sequence from 0 to 2 pi, and then I'm going to calculate the values for y by doing sine of x. Okay, so if I start off at 0, then you will get the sine curve, right? All right, so basic plot, you import matplotlib.pyplot, all right, and basically we're going to call pyplot or .plt.plot, and in this case you can just give it these two arrays, one for x and one for y. And here, let me just show you what happens if you just do that. So plt.plot x comma y, then you'll get this, and it kind of just auto does stuff, right? And you can add arguments along the way. So if you wanted to add a title, you can do that. By default, it kind of gives a little bit of a buffer before x and after x. And so if you wanted to just say, hey, I only want you to go from 0 to 2 pi, you can add x limits, and then we often call plt.show to kind of show the results of the plot that we're doing. So here is with the additional arguments. This is the same thing pretty much, but now we have a title. Yeah.
On the first graph, why does it print a sine function? Is that just a default?
No, because we created x and y. in the previous two cells. So you need to, so the plt.plot is going to basically plot all of your points, and here our points exist in two vectors. One vector is x that goes from 0 to 2 pi, and the other vector is sine of x. Now I could have had any other kind of function or any other kind of values, right? I could say, you know, y is equal to x squared, right? I could have, if I did this, let's see, y equals x squared, okay? And now if I plot this, now we get, you know, a quadratic thing, okay? But that's not what I want. We have y as the sine of x. I'm going to go ahead and plot that. We'll get sine of x. Okay. Here I'm creating a new vector. So x is going to be 0 through 5. Okay. Step size 1, and then here I'm going to say I want, or I guess range 0, 0, 5. So 0, 1, 2, 3, 4. And then y is going to just be random values, random integers. And I can plot those, and I can just do plot x and y. The default behavior, so my values are 1, 0, 5, 9, 1. Default is to connect them, connect these things. If you don't want them to be connected, so that's default of plt.plot, you can call plt.scatter, and it just puts the dots. Okay, so here I just created two vectors of length 5, and I'm just kind of plotting them. So you can have dots, you can have them connected with a line. All right, let's go back. So here x is going to be linear space 0 through 2 pi. Y, I'm going to calculate sine of x. Z will be tangent of x. W will be cosine of x. Okay, and so I can say, all right, let's plot sine of x and tangent of x. And here in both of these cases, so this is why I have all of these together here. So one, if I just did plt.plot x comma y blue, okay, then we'll get this. And then if I did plt.plot x comma z comma red, okay, then we get that, right? We get these kind of separate graphs. But here, if you do it within one code cell, I got plt.plot xy, plt.plot xz, and then I do plt show. Okay, now both of them, you can see a blue line here. Okay, both of them show on the same graph. Right, so if you just have one thing with no additional arguments, it'll just kind of plot it out. But sometimes you want to like add on to the plot, so you can call plt.plot x, plt.plot z, and then plt.show. One of the issues here is what? So the sine goes from 0 to 1, right? Sine has a range of 0 to 1, whereas tangent technically goes from minus infinity to positive infinity, and it doesn't go from minus infinity to positive infinity. I think the largest value we get is negative 300, and we get positive 300, and over here, just because the way we've linearly spaced these out, I think the largest value is like 100. But even then, that's enough to just dwarf the range from -1 to +1. What did I say? Sine was -1 to +1. It's enough to dwarf that we see. Basically, it looks like a flat line here. Okay, but that's not the case. So, but you know, it looks better if we did y and w, which is sine and cosine. And here we can kind of plot these two together. So again, you can within a single code chunk, you can call plt.plot multiple times, and it will just kind of add to the existing plot. And as it does this, before you call show, it's going to automatically adjust your the scales, the vertical axis, the vertical and horizontal axis. It kind of looks at, okay, what's the range of y, what's the range on z, and it says, okay, when I plot this, this is how big I need to make it. Okay, when I plot this, this is how big I need to make it. So it just kind of automatically does that for you when you call plt.plot multiple times, and then you finally call plt.show. All right, is that okay? So that's like the basics here. All right, so let's just show some things. Again, if you want to kind of just make modifications to your plot, you're going to just continue calling the different methods associated with PLT. So PLT is the PyPlot. So you'll do you'll start off with plot. You can change the title. You can change the X label, the Y label, and so this is just adding labels. Okay, yeah, to the X, the title, and Y, and that's that. Okay. You can, I think we've already shown how to do this to modify the X limits. So by default, it puts in a small gap before your first X value and a small gap after your last X value. And if you want it, you can specify the range. And then there's another option, axis equal, and this is for what is it? It's for the aspect ratio. So if you don't specify axis equal, you could create a plot of what's supposed to look like a circle, x squared plus y squared equals 1 or something like that, or you have to turn it into, I guess, y equals the square root of, 1 minus x quantity squared or something like that. Okay, and you get the top half of the circle. If you don't specify axis equals 0, it's not going to look like a circle. Okay, but here with axis equals 0, then this is the true aspect ratio. Something happened with my X limit. I think, I put investigate later and I never investigated this. Let me see. If I do, okay. You have to put, I guess, X limit after you modify the axes. Okay, so X limit here, we do that. Okay, so aspect ratio. Okay, so that's the resulting plot. That's what we get. Yeah, question?
So for some reason, like on my chart, it shows the y-axis as double values, so like 2.0, 1.5, 1.0.
Yeah, I'm not quite sure how to control that, actually. There's probably something in the documentation. Matplot live y-axis float values. Let's see, format. Axes.format y data. Okay, well, there's y label. Limits of y-axis. This doesn't have what we're looking for. Oh, you'll probably have to search online kind of for how to either get them to appear as integers or floats or something. Did you have another question?
Yeah, so I was wondering, is it possible to assign plots to variables so that you could like store them instead of having to fully replace it every time you want to make a new one?
Like in ggplot. I'm trying to think. Maybe? Let me see. I guess we can try it. Why is this not working? Okay, so I can do plt.plot x comma y. I'll store this as, I don't know, p? Oh my gosh, that's like an R thing, huh? Okay. So there's p. Can I do p.show? Yeah, it doesn't like that. Yeah. No, because I'm calling, because when you call plot dot, it's, yeah, this is I don't know.
That like does have like an object-oriented like another way to do it.
Yeah.
Where you can like store the figure and axes objects into variables.
Okay. All right. Send me some links or whatever to documentation or on that. Do you have a thing pulled up? Maybe.
I can search it up right now.
Okay. There probably is a way to do this. I just don't know it off the top of my head here. And all right. Well, here's just another thing. Here I'm going to make a scatter plot. I'm doing still the sine and cosine curves. Y is sine and W is cosine. Here I'm setting the size of my marker. So scatter plot does dots. So here it looks like it's a smooth line, but it's not a smooth line. It is, how did I define x? X is actually going from 0 to 2 pi of length 500. Okay, it's just a whole bunch of these values from 0 to 2 pi, and we asked for 500 of them. And so they're just a whole bunch of separate dots, and they're all kind of very close. Okay, and here I'm going to say D for diamonds and H for hexagons, and you can specify the color of your dots. And here I'm going to say the color is maroon, and the color is dark slate gray, and we can do this, and this is kind of what it looks like. So here's the sine curve. This is cosine, and here I said the x limits go from 0 to 0.2, and it plots this, and this is just what it looks like. Okay, and it's just over here they're all kind of connected. So that's a thing. Here's you just have some options here, and so here I'm just going to plot a line of x plus 1 and x plus 2, x versus x. And you can specify what color you want. B for blue, G for green, R for red. And now you got blue, green, and red lines. And you can specify, basically, these are the single color shortcuts. So blue, green, red, cyan, magenta, yellow, black, and white. So, so if I wanted a black line or a cyan line, I can do that, right? And so you can just kind of change what color you want with single colors. There are also some named colors, and so here are your base colors that are single letters, and then you have a bunch of these kind of. How do I make this bigger? So you have dim gray. I guess gray is spelled both with an AY or an EY. What is the proper way of spelling gray?
I think it varies,
Is it both accepted? Nobody cares?
I think with an A is European.
Is it? I don't know.
Okay, syntax.
Okay, well, and then you got all kinds of colors that I've never heard of. I didn't know this was a thing. All right. Old lace.
Chocolate doesn't look like chocolate.
Yeah, none of these colors. And then this projector is also it looks different here than it does here, right? Is there a difference between maroon and dark red?
I think maroon's lighter.
I can't tell. They had a test on can you differentiate between a bunch of colors, and it's I don't know. I think I was around the 50th percentile or something, right? Versus some people, they can you have these shades and they're just
All the whites look exactly the same.
huh?
Oh, I was just saying all the whites look the same.
All right. So anyway, you got a bunch of stuff. So here what did I use back here? Maroon and dark slate gray, and I guess I could put in whatever, dark magenta. It's the same thing as purple. I don't know. All right. Why bother having a color like dark magenta if it's just going to be the same thing as purple? Well, anyway, a good rule of thumb, though, don't use more than this many colors in a single plot, okay? Because once you go beyond a certain number of colors, like, you're going to run into problems where it's like me, and I'm like, oh, I can't tell the difference between purple and dark maroon or whatever it was. Dark magenta, okay? So you're like, oh, let's identify these dots. I'm going to be like, who is what? So this, your base colors, I think I can tell the difference between these runs, right? These, you got seven colors here, 8 colors. Probably you can't, it's hard to plot dots that are white, but 7 colors, sure, that's fine. We can do that. Different line types. So the matplotlib does a little bit of a funny thing. To say you want a solid line, you use a single dash. Dash line is 2 dashes. Dot dash is dash. You know, you put in basically kind of like a little miniature version of what it is that you want it to look like, and it will do that. Okay. And then the default behavior is if you don't specify the color and you just keep calling plt.plot, it's going to automatically kind of assign different colors. It's going to say, all right, we'll start off with blue, then we'll do orange and green and red and so on and so forth, okay? But you can see, yeah, these are actually different line styles, and even if all the lines were like black and white, like if you were to print this out, I think you would be able to differentiate between these different lines, okay? I think we only have 4 different lines though. Oh, line styles, let me see. Are there more than 4 lines? Line styles. Oh, I guess you can have different levels of dotted. Dotted versus densely dotted. Densely dotted is the same. Loosely dotted, okay. All right, so you can have different dot densities.
Dotted.
Yeah, right. Okay, well, you know, your goal in visualization is to make it easy for the viewer to understand. Okay, B as in bear is your first view quiz answer. B. First view quiz answer is B. B as in bear. Okay. Other things you can do. You can modify the figure size. All right. So before you call plot, plt.plot or something, you would define properties of the figure. And there's several options, okay? And so, you know, check the documentation. But plt.figure, here I'm going to say figure size. And so the default, I don't know what size this is. I don't know what the default size is. But if you specify 4 by 4, this is what you're going to end up getting, okay? And so here I said 4 by 4, do a scatter plot. I did random values from 0 to 1 for x, random values for 0 to 1 for y. Just these are just random uniform values. And I said, you know, plot these, okay? Axis equal. And there you go, okay? So other options for pyplot.figure are here. You can, if you want to plot kind of multiple things, multiple aspects, then you can have different vectors associated with different attributes, okay? So one is I'm going to have a vector associated with size, and another I'm going to have a vector associated with the color. So this gets a kind of a tiny bit tricky, and I would say, and I'm biased here, but I prefer ggplot over matplotlib. But you know, there's a lot of matplotlib is still very capable. It's just you have to kind of think in terms of the way matplotlib wants its data coming in, and so you need basically vectors for a lot of these different aspects. So if you can have a vector for the size, and so the very first dot I'm going to make a size 1000, the next dot is 600, and I don't know where the first dot is on this data set. It's just random x values and random y values. And then here's, you know, another vector as far as the colors go. I just made some integers, 2, 0, 1, 4, 2, 3, etc. And then the colors, I have these 5 colors, red, blue, green, magenta, yellow. And I'm going to basically select the colors based on their index number. So the first First dot is index 2, which is going to be green. The next dot is index 0, which is going to be red. The next dot is index 1, which is going to be blue, and so on and so forth. And so now I have a vector of letters that I can associate with the color. So here, when I create this scatter plot, I'm going to plot the x and the y values for the plot. The size is s. Size is going to get this vector z, which ranges from basically 100 to 1,000. And then c for the color is going to get this vector c, or this array c for the color. And then here I'm going to modify the alpha to 0.4 for everybody so we can kind of see values that overlap. And so this is our data. This is the exact same data as this, and you can notice like here are 3 dots in a row, and here's like a little triangle down here. And you can see, you know, the 3 dots, but because of different size parameters and different color things, it looks a little bit different, okay? But these indeed are the same 3 dots here, and if you look at this structure, here's a triangle, and, you know, that triangle appears right there, and, you know, other kind of, you know, like a triangle, but these 3 dots are in a row, and it's the same structure and same data, same position, x and y position, just we've added now size information, right? Size information and color information. Okay. If you wanted to, you can also change the marker. Unfortunately, you can't map the markers to a variable. And we have different marker options. And you just have to, like, here's the table of them. So if you do marker star, then it's going to plot little stars, which is kind of fun. But yeah, you can choose any of these. The point marker is this, and the pixel marker is the square, and then the circle marker. So the circle marker versus the point marker. The point marker is just smaller. And then you have, yeah, triangle, triangle down, and triangle up. So you can have all kinds of different markers here. But yeah, unfortunately, I don't think you can map the markers to a variable. I don't know, maybe? Let me see. So here we'll try star, triangle down, triangle up, pixel, and circle. And I'll call these shapes. Yeah, it doesn't like it. What does it say? Unrecognized marker style array. Won't let me do it. So you'd have to, if you wanted to do markers, you just have to use different plot commands. One for the, one for the diamonds, one for the hexagons, one for whatever shape. You can't put in a vector of marker values and do it. Okay. Yeah, so here you can call scatter multiple times with different plot groups, each with its own label, and then call plot legend to do it. So here, random dots for X, I'm going to do red stars, and then we're going to have blue circles. And when I do plt.scatter, I can give it this option called label A, label group A, label group B, and then you can call plt.legend, and it produces, okay, star is group A and circles are group B. And you have that. There is something called subplots. So if you wanted to have a whole bunch of different plots, you can do that. And so you create something called a subplot. Okay, subplots, I'm going to do subplot 2, 3. And we go through and we can kind of name them. and this is a little unfortunate, is the subplots. So this is Matplotlib is based off of MATLAB, and that's why it gets its name Matplot. And MATLAB is 1 indexed, where Python is 0 indexed. So when you say subplot, you say how many rows and how many columns of plots you want. So here I did subplot 2, 3, all right, which means we want 2 rows and 3 columns, and then you specify, which plot. So 2, 3, 1 is the first plot, the top left plot in a 2 by 3 row of plots. 2, 3, 2 is the second plot, which is the one in the middle, and 2, 3, 3 is this plot over here. Okay, and so in each subplot, the only thing I plotted is just this string that tells you which plot it's looking at. So this is 2, 3, 4, 2, 3, 5, and 2, 3, 6. Okay, here is, this is kind of a pain, but you can do this, all right? So here I said, okay, let's do y is sine, z is tangent, w is cosine, and 2, 2, 1. So we're going to make 4 plots, a 2 by 2 kind of grid of plots. 1 will be the top left, 2 will be the upper right, 3rd will be the lower left. And there you go. Okay, so here's sine of x, cosine of x, tangent of x, and then here's sine and cosine in the last plot. So basically, you just kind of specify which plot you're working in, and then you put in your basically plt.plot, plt, whatever options you want for that particular plot, and then you name another subplot and you kind of move over to that plot. And then when you're all done, you call plt.show. You can make more complicated ones with something called grid spec. All right, so you can do plt.gridspec. And so basically grid spec says I want 2 rows, 3 columns, and horizontal and vertical space and stuff like that. The worst part, not the worst part, there's a lot of things worse than this, but with grid spec, it's 0 indexed. So if you want the top left plot on grid spec, you do subplot grid 0, 0. Okay, and then if you want something else, so here, the top left, maybe I should space these out. So the top left is grid spec 0, 0. This one, I did grid spec row 0, which is the top row, and then columns 1, 3, so you're slicing them. So basically these two, and we're going to do a histogram, which is, this is a boring histogram, and then here I did grid spec the next row 1, and then through slice 2, and I did a histogram, and this is what we get. And then the last one, I said grid 1, 2, which is this one over here. So you can kind of do this. I feel, my opinion, is like this is way more effort than what it's worth. I mean, that's just me, okay? But you can, right? You really want to do stuff, and the option is there, okay? It's just kind of like, I don't know, maybe it's fun. It's like trying to build UCLA in Minecraft or something. It's like, yeah, it can be fun, but it's also like, oh, it's like a lot of effort. I don't know if it's worth it, but well. Okay, we can make histograms. There's the function plt.hist. It's very easy, very straightforward. Boom. Okay, so here's some, I just generated some random normal values into an array. So this is an array I called plt.histogram. Okay, you can change your options in the histogram, bins, color transparency, what color you want, and what edge color, right? So the fill color and the, in R we had like fill color and stuff like that. But here you can just say, okay, so same histogram, but I want more bins, and I want the inside to be this color and the edges to be that color. There are a few different options. So one is step filled, which which does this, which kind of has a cool look. So it outlines it in black, but it doesn't put the lines in between. And so that's just a stylistic preference. Doesn't actually change anything. And again, more options regarding what kind of things you can do, right? So histogram type, bar stacked, step filled. An animated histogram. Look at that. Okay, I don't know how to do that. You can read the documentation there. So here's kind of a cool thing. So remember, we have tuple unpacking, and we can also have dictionary keyword unpacking. And so notice these are the arguments that I'm feeding into histogram. Is I can say, what kind of color I want, what kind of edge color I want, the histogram type, the alpha. That in this case, I want to plot also not the count, but the density. All right, how many bins I have. And so here I'm going to have 3 normal distributions. One is centered at 0 with a standard deviation 0.8, one centered at -2 with a standard deviation 1, one is centered at 3 with a standard deviation of 2. And for all of these, I'm going to do plt.histogram. And rather than having to, so one way I could have done this is I could call, I can do plt.hist, and I could say, do x1, and I could paste all of this, right? Copy and paste, and say color equals navy, okay? And then I can do plt.hist x2, and I could paste all of the same things, right? Copy and paste. We're all accustomed to doing copy and paste. This is not anything surprising to us, right? And we could do this. Instead of copying and pasting the contents of this dictionary into here, I'm going to store the dictionary as KWARGs, keyword arguments, or we just call them QWARGs. That's the convention. You just call this QWARGs. And you can do a double star, and it will unpack the QWARGs as arguments into the function. And that will work. And then you can do this, and it will create the plot. And that way, if you wanted to later, you wanted to change it, right? And you wanted to say, oh, you know what? Edge color, we want to do red. Okay, you can do that, and it will change it everywhere, rather than having to go in and say, oh, I changed it here, and now I have to remember to also change it here, and so on and so forth. So that's one of the nice things about rather than having to copy and paste the same settings for every single plot, you can store them in a dictionary and then unpack them as QWARGs. Okay, next view quiz answer today is E. E as an elephant. E as an elephant. It's your second view quiz answer, E. Okay, here is a 2-dimensional histogram. I'm gonna have a mean of 0, 0. This is my variance covariance matrix, and you can call random on the multivariate normal. So you get kind of like an ellipse of points. And here I'm going to call histogram 2D histogram. And ta-da, this is what you get, okay? And then you have basic other kind of similar things. Here's hexbin, which looks kind of cool. I don't know. Huh? Yeah, it looks like it's kind of just blurry, right? But yeah, that's more points are dark or something like that. You can create a 2-dimensional function. So there is so x is a vector or an array 0, 1, 2, 3. Y is another array -1, 0, 1, 2. And I can create what's called a mesh grid. Okay. So if I come back and I just say, what is capital X? So I'm going to do mesh grid on X, Y, and store it as capital X and capital Y. X is a large array, and Y is also an array. Basically, we've just remember when we did broadcasting, and we did something like, take, a row, basically a one-dimensional, or not one-dimensional, one row, 5 columns, and basically five rows, 1 column, and then we added them together. What Python did was it broadcast it both into like 5x5 things. That's basically what MeshGrid will do, is it will take your vector that you supply it and it will broadcast it into, in this case, why did I have to say x as length 3? Okay, well, here, x is length 4. So basically it broadcasts it into a 4x4 thing here. And then what I can then do is I can take my mesh grid and I could feed it into a 2-dimensional function. So here I have a 2-dimensional function that's just going to take x and multiply it by y. And I could say, all right, run your function on this mesh grid x, mesh grid y. And what it's going to do is it's going to produce z, which will also be 4x4. And the result will be the product of, each kind of thing together. So here you can see, oh yeah, when you do 0 times, this column will end up being zeros, this row will end up being zeros, and here we get -1 times over here, and then 1 times over there, and 2 times that. Okay, so you can, if you see what x is and what y is, you can see how MeshGrid calculates the values for every combination between x and y. Okay, so if we wanted to do this, maybe for a bigger thing, I'm going to create values from -3 to +3 for x, -3 to +3 for y, and then the function is going to be the PDF of 2 normal distributions here. Okay, so this is going to be a big grid, 101 rows, 101 columns, and there's a few kind of plots we can do. One is I can do a contour plot between x, y, and z, and if it's 2 normal distributions, it's going to look like this is a top-down contour plot of, I guess, contour plot of multivariate normal. And so the idea, this is the same plot we have here, but so here is kind of this is what the multivariate normal looks like, and basically the contour plot is just like, if I slice this, and I slice this, and I slice this at different elevations, what does that plot look like? And it's going to kind of look like a whole bunch of concentric, in our case, circles, but if you had covariance, you'd have ellipses. You can also do image show, and it kind of it chooses this color scheme where higher values get a different color and lower values get a different color. So these are just some options on kind of plotting some stuff here. Okay, you can take a data frame, and Pandas data frames actually have plot methods associated with them. Oh, we might have to spend a little bit more time going over some of these examples here. I'll save some of these for Monday. But for example, here's a time series. So I just said, okay, do a date range starting January 1, 2000. I guess, I don't know. And I guess I said make 1,000 of these things. So that takes me from January 1 to year 2000 to September 26, year 2002. Okay, and I just did random values, random normal numbers. Sometimes we get big numbers, sometimes we get little numbers. And then I'm going to do cumulative sum. So the cumulative sum starts off here, and we basically go up or down. So this is just a random walk, and this is a Pandas series, and with a Pandas series you can just call plot, and it plots it, okay? And it recognizes, oh, you have the index. The index will go on the x-axis, and the values in the series I'll plot as the y. And so here, this is just kind of a random walk either, you know, we go up or down on any random given day, and we just happen to have end up at 11.199, but you know, we went as low as almost negative 40, and there were some days we just had a whole bunch of like positive values every day after day. So, you know, sometimes stock charts look kind of like random walks and things like that, and that's kind of what we get. So anyway, there's more plots associated with Pandas data frames, and we'll I guess we'll take a look at that on Monday. Let me give you your last view quiz answer. Last view quiz answer is D. D as in dog. D as in dog. D. Okay, we'll wrap it up for here today. Have a great weekend. Have a safe weekend, and we will see you on Monday for Halloween to celebrate. So I don't know. Okay. Well, anyway, we'll see you Monday. Have a good weekend. We'll see you then.